So, welcome to our talk. I'm Michael Schmeißer from MGM Technology Partners, and we build software for business customers. And we like to take long-term responsibility for large projects, so like projects which run a few decades possibly. So for that, it is really important for us to present technology stacks and architectures to our customers which will be feasible for a long time. And of course, we also want to have our customers trust us with what we suggest and what we do. And of course, we can build that trust with references, with who we are or projects that we have done. And probably the customer will believe in that. And that's a nice thing. But it's even nicer if you can show something really to the customer, where the customer can see, okay, this is the particular technology stack which they suggest, and it works, and I can play around with it. That's much better than slides or people talking a lot of stuff. And so this is what we like to use or what we want to use. And this is especially important in the big data world because you know it all. In big data, there is not one single solution stack, and you apply this to all problems, and then it's solved. But rather, there's a really rich open source ecosystem, and technologies get added all the time, and also their maturity changes a lot. So you really need to be up to date, and you need to suggest technology stacks that actually make sense for the problem. And we are not on our own with this. There is also some research in this area, and research centers, universities, which are kind of interested in this topic. And for example, in Leipzig and Dresden, we have the SCADS, which is a competence center for big data and data science topics. And what they do is they cooperate with the industry to basically derive research topics from what the industry needs and give this knowledge back to the industry. So the two colleagues next to me, which is Martin Grimmer and Matthias Kricke, they are working for this competence center, and we have a close relationship to MGM. So to come back to what I've said before, showcases or proof of concept for a given technology stack are really important to show to customers that something could work and they really believe in it. They see it and they say, okay, I have a very good feeling that we should solve it that way because I can basically see it and play around with it. And to do so, we basically have several options. One option is we take something that we have done for a customer and show it to some other customer. But most of the time, this does just not work because basically because we are not allowed to show it, or because it depends on some data that we are not allowed to show, or because it depends on some infrastructure that we can't use to show it to some other customer. So this is not really feasible. Though it's interesting, it's most of the time not really feasible. Maybe you have some slides that you can show to other customers, but some running proof of concept, most of the time that's not the case. And another option is to build basically such showcases or proof of concepts on our own. But well, that's also difficult because it takes time. And especially with some complex big data technologies that we may not have used that extensively before, it might take some time. But we figure out a way to solve it, and I'll show you in a minute. But before that, let's head over to the goals that we've had for this specific proof of concept called OSTMap. Well, it should address some soft and some hard goals. One of the soft goals, I've already mentioned it before, is to build trust for big data technologies in general, and for some particular big data technologies, which in this case includes Flink. And well, with almost no experience, because we didn't work with Flink extensively before. And so it's basically start with zero experience and try to build something and then show it to a customer. Is this good? Yes, it is, because you can surround it with things that you have done. If you have basically, for example, used Spark, and you can say, we've worked extensively with Spark. We did something now with Flink. It's quite similar. There are some differences, but it also works. You can see it here. So that's a nice thing to have. And another thing that is always difficult is to get new employees which are experienced in big data. It's difficult to get senior staff who have worked for a long time in the big data area. And it's also difficult to get, well, basically students who have finished their studies and now join your company. They most of the time don't have any big data experience. And why is that? Well, that is because universities don't transfer this knowledge because, well, they rarely have any modules which cover those topics. And if they have, they're mostly not focused on real industry use cases. So we as MGM also see our responsibility in forcing this knowledge transfer into both directions so that we go to the universities and say, okay, we would like to get students in touch with big data. And this works very well with things like the SCADS and also like the University of Leipzig, with which we did the OSTMap project in cooperation. So this is basically this topic. But we also really didn't just want to make some project and students play around with big data technologies, and that's nice. No, we really wanted to take this opportunity to build a showcase that we can actually use to show it to customers or basically show it to everyone who is interested in that. And this showcase should include a real-time application to view recent tweets on a map. So basically, you use Twitter, you tweet something, it's geotagged because you use your mobile phone, and we just want to show that on a map. And we want to do this in real time, because one of the real interesting upcoming things is real-time processing. Not real-time in the sense that it's hard millisecond limits, but real-time in the sense that the user doesn't really notice any significant offset, like every 10 minutes we run a MapReduce job and then we can show something. No, it should be tweets are made and then we can show them on a map and there's not so much offset between it. Basically an offset which is not noticeable for the user. And we thought that this should be really easy to do with Flink because Flink supports stream processing and we amended with some other technologies to store data and then it should work nice. This was our idea. So this was also our requirements to this project. And we also not only wanted to show all tweets, this is not so interesting, we wanted to make it possible to search for terms and users, terms in the sense of both textual terms and also hashtags. And they should basically filter the map. And what was also interesting, but rather a plus, not one of the base requirements, but something that we wanted to add then step by step was to build some data science jobs which do some more interesting evaluations over time and compute some statistics. So I've mentioned it before, we did this in cooperation with the University of Leipzig. So basically, 3 of us were only mentoring the project. We are not actually building the thing ourselves. We also provided the infrastructure with a setup cluster where all these technologies are running. But the application itself has been developed by a group of students. And those are the 6 students that you can see here. And they developed it in a module which basically allows students to get in touch with the industry and do an industry-mentored project over a course of 6 weeks. And during those 6 weeks, they did not invest their entire time. It was a part-time module, which in the end resulted in 5 ECTS for each of the students. And because 6 weeks is quite tough, it's not so much time to build something. We had weekly meetings to make sure that the focus still stays there and we make a continuous progress. And we also wanted to take some lightweight agile approach so that we have something that we can show in the end, even if it's not full-fledged. We have some basic features. We can show tweets in real time on the map, and then we iterate on that and add features as time goes by. So to do this, we followed the walking skeleton approach. So basically, we've had multiple components. Martin will talk on that more in a minute. And we glue them together from the first moment so that we can show something. And then as time goes by, we add feature by feature and increase it until we finally have our final presentation where we then show the result. And the result is also open source on GitHub. So if you want to have a look at that, you can do so afterwards. So as I said before, Martin will now take over and explain what our milestones were. And he will also show the real application that resulted in the 6 weeks.
OK, thank you. As Michael said, we used the walking skeleton principle. And we had several components glued together. And our first milestone was to simply collect tweets and display them as a list on a user interface. And we did this by using Flink. It ships with a Twitter example. And we just modified it a bit to collect the Twitter stream regarding all geotagged tweets from Europe. We stored them as plain JSON files, and via the web interface, it was possible to query for specific terms. Okay, the next step was to enhance each of the components. Specifically, we exchanged the storage backend from simple files to Accumulo. Distributed column, no SQL database, like HBase, for example. And now it was possible to show the tweets on the map, like you can see on the right side. But this whole thing wasn't really fast. We had several problems with performance, as one can imagine, because we didn't have any advanced searching techniques. In the end, each query was a full table scan on all tweets we collected up to this time. And in addition to this long query times, we had the problem that the visualization had it was really slow because there were almost 100,000 points on the map to show. And since it was rendered in JavaScript, it wasn't really fast at this time. So we did a step forward. We could show them on the map, but it wasn't enough. So the next step was to increase the query times and the visualization. And we came to this state, our third milestone, with several UI improvements, like clustering of tweets to improve the visualization times. And it was possible to search for user tags or text tokens for hashtags via a term index inside of Accumulo. It's no fancy thing. It's simply a table with each term occurred in all tweets for simple lookups. In addition, for the faster query times for our map search, we added a geotemporal index. That's an index over 3 dimensions, namely the geospatial space and the time space. And I'm going further into details later on, but we achieved query times under 1 second for most queries, I would say. Okay, if you zoom out to show the whole country or the whole continent, the query times may be bigger, but for our use case to show the recent tweets, it was really feasible. In OSTMap, we had 3 parts. That was the streaming processing to ingest the geotagged data into our backend. We used Flink, a streaming processing engine, to extract the needed data from the stream and to calculate the index structures. Then we had the second layer, the batch processing layer. Here we used Flink as well with the dataset IP. As Michael said, this was more like a secondary goal. We did only simple jobs for this part, but the third part was the querying part, which is a user interface, and this was really easy to achieve within this short time frame with usage of Spring Boot and Accumulo. So let's take a look at the first part, the stream processing. And since we used the walking skeleton principle, we had a really simple approach at first. We simply read the geotagged data, extracted a timestamp from it, and generated a key on our first index, and time index, where we stored all tweets. This enabled us to build the first version of OSTMap, which allowed queries against the whole data set, but we have full table scans, which resulted in really slow responsive times. So the next step was to add additional indices and a little bit more complex stream processing. You can see this on this view. We have the time index wasn't changed at all, but we added a term index by tokenizing all texts incoming and building up this term index. We added the geotemporal index, and for a little bit more sophisticated stream processing, we added the fourth layer here, the language frequency. We counted the occurrence of each language within the tweets and built 1 minute windows and simply summed the number of tweets for each language and wrote it back to Accumulo to visualize it later. This is the current state of our stream processing layer for OSTMap, which does all we need to achieve these pictures you already see. We have a live demo at the end of this talk. Hopefully it works now, but I'm sure we get it running. The one single thing I want to say about the second layer, the batch processing layer, we plan to add additional batch jobs like statistics about what's the area a user spent with all of his tweets, like shown in these pictures, or the path he goes over time. These jobs weren't finished within this university project, but there was a basic code was finished. We weren't able to run it on the data. What we did was a data export tool which simply exports all tweets into JSON files for further usage at the university. And we built 2 batch jobs to convert all for all already processed tweets into our new index structures. Okay, now I want to talk about these index structures with you. I don't know if you are familiar with HBase or Accumulo, but in the end, these are key value stores, and key is a composite key consisting of the row, a column family, and a column qualifier. And for our term index, we simply use the timestamp and a hash value of the tweet for the row. So if we want to know all tweets in a specific time range, we could use a simple scan on this table to get all these tweets. The term index was a little bit, added a little bit later. The row key is simply the term, and we used the column family to distinguish between user and distinguish between the source of this term. Is it the username or is it from the text field of the tweet? And this table doesn't contain the complete tweet. Instead, we used the key from the first table, and we have to make lookups for each tweet found in this table. The third one is a table to store the language frequency I mentioned earlier. We used a simple string variant for the timestamp on the level of minutes. The column family for the column family, we used the language tag like EN for English language. And in the value field, we simply stored the amount of tweets for this language tag in this minute. And if one wants to know all, for example, the count of all English tweets within an hour, one simply has to start a range scan with the accuracy to the hour, because in Accumulo and the tables are automatically sorted by the row key. Okay, these are the three more simple tables. Let's go on to the geotemporal table, the geotemporal index. But before we talk about the geotemporal index, we want to talk about the geoindex, because it's a little bit simpler. Let's think of geodata. Geodata consists of two dimensions, latitude and longitude, and we have to map these two dimensions into one dimension, into our one-dimensional key space in Accumulo. And for this, we used set curves. In this particular approach, we used geohashes. There are really good libraries for this out there, so we didn't have to implement these details by ourselves. And so one can see the feature why we used geohashes is that 2 points on the map which are near to each other are often also near to each other in the key space of Accumulo. I try to show this by coloring the regions there. This led us to the table shown in the top right. We used the geohash as row key, and the column family was the key in the time index. So we didn't have to store the tweets a second time. So one may ask how to query such an index. So let's assume one wants to query a bounding box. And this bounding box does not have to match exactly on these underlying geohashes. The bounding box is so it's given by 2 coordinate pairs. And the first step is to calculate the coverage of such a bounding box, which results in this case, it's the geohashes 9p, 9r, and D0 to D3. From this coverage, one has to calculate scan ranges for Accumulo. In our case, these 3 scan ranges, and in the end, we have to do 3 queries to Accumulo to cover this whole region. One additional problem here is that we would get results outside the bounding box, but inside the geohashes. So we added a server-side technique after this, and this technique is called Accumulo iterators. These are server-side programs running inside the Accumulo table store. And for this to function, we need to add the accurate coordinates to the table. As you can see there, we added the latitude and longitude coordinates. So before the data set or the entry in Accumulo is returned to the user, it is filtered by the exact coordinate, and we achieved really good querying times with this technique. So now we are able to querying for geospatial information, but as the topic says, we want to get geotemporal data, so we have to add a third dimension, the time dimension, and for our use case it was possible to achieve this by simply adding one time bucket for each day. So it was really easy. We ended up with one geospatial index per day. Since we want to show only the recent tweets on a map, so we have only to look up in one or two of these buckets, and this reduces the search space in a large scale. This resulted in a prefix, in our row key. Another problem occurring with these techniques is a problem called hotspotting. Let's assume all tweets from like Germany are mapped to the same geohash. So all data from these tweets will result on the same node in the cluster, and this isn't what we want to achieve. We want to achieve scalability, so we have to spread the data across a cluster, and this was done by a technique we call spreading byte. We simply add another byte to our key in front of our key, which was calculated simply by a hash value. And in addition, one has to define pre-table splits in Accumulo as shown here, so that each node in our Accumulo cluster can handle data with a specific key. And to show that this works, we want to show you a demo. Okay, this is the term search, but let's start with map search. What? Okay, one moment. Now it should work. Yeah, okay. Thank you. Now we here are in Berlin, and we want to show all tweets of the last hour simply by moving around in this map. And one can zoom in. And did anyone tweet about this talk now? Yes? Was it a geotagged tweet? This is, yes? Okay. It should be here. Maybe we can see it on the map. Okay? Okay, Matthias was really active, but we can search for hashtag FF16. This uses our term index, and we get, the problem is, there was another festival here in Ireland, but we can see here are some tweets with this hashtag. For example, okay, this was a deleted tweet, but here's another one. we can navigate through this. What's your username? Did you find yourself here? Here's a test. Jonas, are you here? Okay. Only one tweet from you here. Okay. Was it geotagged? Okay, then we don't have it. Yes, or we can use it for, I think.
What about streaming? So if somebody going to a version, okay, FX16, somebody is post a tweet right now, it will post it.
Yes, let's try it. We have the last 15 minutes, take auto updates into account, and I only have 2 tweets, which are, okay, this from Matthias and this one. Okay, here's another one. I don't think it's from us. No, it's not. But we can see we have only 2 tweets with this hashtag in the past 50 minutes here. Maybe you are located elsewhere. 4 tweets. Here are 2 other tweets. This was a test, and sure, this is possible. Maybe we should take the last hour into account. And there were 24 tweets with hashtag Berlin, geotagged tweets. So one has to take into account that only geotagged tweets are collected by us. And this is less than 1% of all tweets in Europe. Because Twitter is giving only 1% from the whole stream to a non-paying user. Okay. I don't know it. Sorry. Okay. Do you have any questions? Okay. I forgot one thing. We talked about the language frequency, and this is a statistic about the last 4 hours with, one moment, with a stacked bar chart showing how much tweets were done in a specific language at a time. Yeah, okay.
Thank you very much for the very interesting talk and the demo. Like, really interesting. Thank you very much. Any questions? So, one right in front.
Yeah, so why did you choose for the Apache Accumulo database and not for Cassandra or Elasticsearch, or Elasticsearch has more geo-ready information there, right? So geo queries stuff.
There were several points. One was the capability for range scans. We use this technique with hopefully few range scans to achieve a good lookup rate. And the other point was to teach students key value stores. we could take HBase into account also, but we simply like Accumulo, I think.
That's good enough reason, huh?
Any more questions? So I have one actually.
Okay.
And so my question is, instead of using the square grid, you could also use some other grid that basically is based upon the density of tweets from that area. You did that actually later on, but you could originally go with a different kind of a grid. So did you think in that direction?
We previously we think about it. We had a master thesis in our company, which researched in this area, and the result was that geohashes are good enough, not the best technique, but good enough and fast to implement. And since we wanted to achieve this in a short time frame, we did it with geohashes as Z curve.
That's very interesting.